All right, so I'm gonna go ahead and explain the special right triangles. The one for the right now, we're going to do the 45, 45, 90 triangle. It's also known as an isosceles right triangle. That means two of the legs are going to be the same. So we have our right triangle right here. And this angle right here is 45 degrees. This angle down here is 45 degrees. So both of these angles are the same. And the consequence of that, since these angles are the same, these sides directly opposite are going to be the same. So we're going to call this length A, and we're also going to call this length A. To actually find the hypotenuse, what we're going to do is actually just the Pythagorean theorem, nothing fancy. We're going to do A squared plus the other side squared. So it's leg squared plus leg squared equals my hypotenuse squared. Well, A squared plus A squared is nothing more than 2A, but when we combine like terms. So now I have 2A squared equals C squared. I'm going to take the square root of both sides. Don't forget your plus or minus. So we have this plus or minus the square root of 2A squared equals C. Then we have some square root rules involved that you actually learn in Algebra 2. But this actually simplifies. It's going to be the positive because it is a length. Length is always positive. And then A squared is going to come on the outside, and we're going to end up getting A square root 2 equals C. So my hypotenuse here will always be A square root 2. So if you actually know A, you know all three sides really, really fast of a 45, 45, 90 triangle. All right, so let's go ahead and start. Let's do an example. So we still have our 45, 45, 90 depiction right up here. But what we're actually going to do is I'm going to do an example here. In this case, it's going to be the hardest possible example that I could give you. I'm going to say the hypotenuse is 14, and I actually want to find my side lengths here and here. The way I'm going to actually do this is I'm going to look at my basic form here, and I know that my hypotenuse is A square root 2. And I know my hypotenuse here is 14, so I'm actually going to set those equal to each other and solve for A, because once I know A, I'll know both legs. So we're going to have A square root 2 equals 14. From here, we're just going to do some basic algebra. We are going to divide both sides by square root of 2. And I get A equals 14 over the square root of 2. Do not leave your square root in the denominator right here. We need to go ahead and rationalize our denominator. The easy way I remember it is I'm going to multiply this by 1. But it's a special type of 1 I'm going to multiply by. I call it a fancy 1. So I'm actually going to take my denominator, the square root of 2, and I'm going to multiply the top and bottom by square root of 2. When I do that, on the bottom, on the top, I just get 14 square root 2. On the bottom, because they're the same square root, I can multiply the numbers underneath, and I get the square root of 4. Well, the square root of 4 is nothing more than 2. This leaves 14 square root of 2 over 2. And of course, 14 over 2 reduces to 7. So A is actually 7 square root 2. So in this case, both of these sides are going to be 7 square root 2 and 7 square root 2. This is the hardest example I can give you where you have to rationalize the denominator.